Hello, in this example, I'm going to help you solve a problem similar again to the one you have for homework. So we're asked again, without using a graphing calculator, obtain the following information about the quadratic function. All right, so let's try to do this again without the use of a graphing calculator. Doesn't mean we can't use the calculator to do some of the arithmetic, but at least not go straight into the Desmos and graph this and see if it's going to have a max or min. Now, for that first part, determine if the function is going to have a maximum or minimum value. We rely on this value right here, which is the a, quote unquote, a value to this quadratic equation. Now, because that number is a negative, that means that the quadratic is going to open downwards, and thus, therefore, the highest point, our vertex, is going to be our highest point. So we have a maximum here. Now in the homework, you could write the word maximum, or you could write the abbreviated form of that, which is just max. So both of these are acceptable. Now, to determine where the maximum is located, well, we're going to use the formula. So we're going to use the formula that we use to find the axis of symmetry. So to locate, again, where the max is located, we're simply identifying the location of this vertical line, which the formula for that is x equals to negative b divided by 2 times the value of a. Now to get the values of a and b, we're going to get those from, again, these two values here. The a value is this number, like I mentioned earlier, and the b value is the second term here, the coefficient to x. So substituting in those values, we end up with negative b, which is 9, divided by 2 times our a value of negative 8. And that equals to 9 divided by negative 16, which is 9 over 16. Now, even though, again, I don't want you to use a graphing utility, you can use the calculator again to simplify this fraction if you need to, or to evaluate and get this exponent value there. So let's go into Desmos again. And I have the equation right there, so I don't have to go back and look at it. And I hit it, all right? I don't want to see it to see if I have this information right into the very end. So to figure out, again, the location, in other words, the axis of symmetry, I need to get the opposite of b. So I'm going to fraction. So the negative of my b value, which is the number 9, like I mentioned earlier, divided by 2 times our a value, which is the number of negative 8. So that gives me this decimal value there, which is, like I mentioned, the same thing I got on when I did it by hand, 9 over 16. So I have this 9 over 16. That's the reduced form of this. So this is our location. So the max occurs at x equals to 9 over 16. On the homework, you do have to write this as an equation. So you do have to write as x equals 9 over 16 will not be marked correct if you just write 9 over 16. Now to find the minimum value, oh, I'm sorry, to find the maximum value, again, we know it's a max. Now to find the actual maximum value, what we're doing is identifying the y coordinate to, again, this vertex. So now that I know that the max occurs again here, this is where the axis of symmetry is, all I need to do to figure out the actual maximum value is find what the y value is to this equation when x equals to this number. So we have negative 8x squared plus 9x minus 7. So negative 8 times 9 over 16 plus 9 times 9 over 16 minus 7. Now I definitely do not want to do this calculation. Let's not forget that square there by hand. So let's use Desmos again. Again, all I want to do is avoid using the graph, okay? I want to get these numbers by hand and know how to do this without relying on the actual graph itself. So, but we can go into Desmos and at least do this calculation as a shortcut so we don't take too much time. So we have negative 8 again. We're going to replace the x again with this number of 9 over 16. Don't forget that the first one needs to be raised to the second power. So raise that to the second power. We're going to add the 9. Again, replace the x with this 9 over 16. And then subtract 7, which gives us this decimal value. And as a fraction, That's negative 143 over 32. Did I say 42? No, 32. I thought so. I thought, look, no, I'm wrong. So 32. Let me fix that. So this is your maximum value. And again, just like with part B, for part C, you do have to write it as an equation. Now, what is the range of this thing? Using inequality, identify the function's range. Well, since this point, again, is going to be the highest y value, again, that's where the vertex is going to be the highest y value. The range, which are the y values, are going to be all the values below that. So they're going to be less than 143 over 32. So y would have to be less than or equal to that right here. And again, since this one states that you have to write an inequality, obviously you have to write as y is less than or equal to. Now, if it was a max, then it would just simply point in the opposite direction, and all of this stuff again would be the opposite as a result. But this is again what you'll do. And the only difference between identifying the max and the min is that what this value is. You'll do the exact same two steps for this one and this one, regardless if it's a minimum. But the inequality over here would just, well, that's the only thing that will be different. Then instead of being less than, it will be greater than if this happened to open upwards instead of downwards. Now, let's look at Desmos and see if I could, if this matches up again to the values that we have here, okay? So if I go to the graph again, which I was trying to avoid, I see that the maximum is occurring again at this decimal value of 0.5625, which again is this 9 over 16 as a decimal. You see I have that one right. And the minimum value, I'm sorry, the maximum value is negative 143 over 32, which as a decimal is negative 4.46875, and yep, that's the exact same value. Now, to kind of force you, not really, but to try to kind of force you to do it this way and not go straight into the graph, these x and y values, these a and b values, again, these quadratics, are going to find these vertex at these decimal values. And some decimal values are going to repeat infinitely, so it might not give you the correct fraction notation for that. So there's a big difference between having the number 0.5625 and the number 0.5625 that repeats on forever. Okay, but if this number was repeating forever, notice that the value again is going to be different. And that's again the key thing with this. Now there's ways again of overwriting this and still figuring out what the equivalent form is if this decimal value was repeating forever. But again, you would just have to know that one. So again, you have to just be familiar with Desmos. And again, the importance of knowing how to do this again without relying too much on the graph itself and knowing where we get these points for these instances that we get in the case that we end up with a decimal that repeats. That's not going to be acceptable in the homework. You have to give me again the actual fraction equivalency of that. And if you don't recognize that your decimal value is repeating, then that's where again it hinders you in relying too much on decimals automatically and getting those maximum and minimum values, this particular again, this x and y value from the vertex, from the calculator, from the graph itself. Well, I appreciate you watching and I hope this video was helpful.